Hey everybody. So what we want to do today is just a quick review of the exponent laws that you dealt with in junior high. Okay, I'm not going to teach you anything today that you haven't done in junior high, but it's just meant for us to just take a second, kind of regroup, make sure everybody's on the same page when it comes to the exponent laws that I do expect you to know by now. And if you're unsure of them, to give you a chance to get sure of them. Okay, so there's a little warm-up problem here. If you'd like to try it, you can pause me and give it a go. And the answer was 5,270 centimeters squared. All right, so now let's talk a little bit about some vocabulary. So a power is a number with an exponent. Now, there are usually two parts to a power. You've got the base and you've got the exponent. The base is the large number at the bottom of the power, and it's the number that will get multiplied by itself. An exponent is the teeny tiny number at the top of the power. At the top of the tower, that's not what I meant to say. At the top of the power, it tells you how many times to multiply the base by itself. For example, 4 to the 5 means 4 times 4 times 4 times 4 times 4. And that would equal 1024. Now you do have an exponent button on your graphing calculators. If you are a Casio kid, it looks like this. And if you're a TI kid, actually, it looks like that as well, no matter who you are. On a Casio, that button will be right underneath your variable button. Or if you find your alpha button, it's 2 to the right of your alpha button. If you are TI, it's right underneath your clear button. Okay, so take your calculator, go for exponent 5, make sure you're able to get the 1024. Okay, so let's just talk about some of that vocabulary here. For this first row, the expression is 2 to the 5. The power would be the whole thing, so 2 to the 5. The base would be 2. The exponent would be 5, and there would be no coefficient here. Okay. Now, for the next guy, something I want to talk to you about here, the power itself is just this, okay? This 2 has nothing to do with that exponent, okay? Rather, that 2 is a coefficient in front of x to the 4, okay? So the 4 does not apply to that 2 because it's not in a set of brackets. So the power itself would be x to the 4, and then the base is x, the exponent is 4, and the coefficient, the number in front of the variable, that's where the 2 will show up, okay? All right, so what does an exponent mean? An exponent tells you how many times to multiply the base by itself, okay? So if it was 5 to the 7, it would say multiply 5 by itself 7 times, okay? Now, we need to explore a little bit about negatives with exponents. To talk about what some of that means. So remember the conversation I just had in the previous slide with that 2. I said that 2 didn't apply to the exponent because an exponent only applies to what's directly in front of it. You have to be super careful with that in this situation here because a lot of us don't quite pay attention to what's going on here. This 2 only applies to that 5, okay? This negative has nothing to do with that exponent, okay? This negative is part of the exponent because it's in a set of brackets, okay? So now that 2 would apply to everything that's inside the brackets, but this 2 only applies to the 5. So this really becomes negative whatever 5 squared is. Well, 5 squared is 25, so it becomes negative 25 as a result. This guy here, though, this becomes negative 5 times negative 5, and so that would be a positive 25. Negative 5 to the 3 would become negative whatever 5 to the 3 is, so that would be negative 125. And then this guy would be negative 5 times negative 5 times negative 5, which is also negative 125. Okay, so the one you got to be really careful with is these guys here. When it's an even exponent, you have to really pay attention to whether you're supposed to include that negative or not, okay? So what can we conclude about negative exponents and bases? Well, we'll conclude the following. A negative does not apply to the exponent unless it's in brackets, okay? An exponent only applies to what is directly in front of it. All right, We're going to play a little matching game. Maybe give me a pause for a sec and see if you can match some of these together, okay? So I'm hoping that you took this and said, those guys go together. When I am multiplying powers that have the same exponent on them, that exponent can really just carry to the back, and it'll be 2 times 6 all to the 3. When I'm multiplying powers here that have the same base, what do I do to the exponents? I add the exponent, so that would equal 2 to the 7. Here, that 2 would get distributed to both the 6 and the 2, so that guy would look like him. 2 to the 6 divided by 2 to the 2. When I'm dividing powers of the same base, I would subtract the exponents, so that would look like that. And then I have a power of a power right here. When I have a power of a power, I would multiply the exponent, so 2 times 4 is 8, so that should match up with that. Okay, good. All right, so using that knowledge, let's just review these. Now, I'm not asking you to give me a number here. I'm asking you to show me that you understand the exponent laws. So 5 to the 2 times 5 to the 7, when I'm multiplying powers of the same base, I would add the exponent. So what I want you to tell me here is 5 to the 9. 4 to the 7 divided by 4 to the 3, when I'm dividing powers of the same base, I subtract the exponents, so that would be 4 to the 4. 7 to the 2 to the 3, when I'm taking a power of a power, I would multiply the exponents, so that would be 7 to the 6. Here, I want you to show me that because this is multiplication, the 6 can apply to both, so this could be written as 4 to the 6 times 5 to the 6. And the last guy, same thing with division. That exponent will apply to everything inside those brackets, so that'll be 3 squared times 5 squared. These guys here don't work if it was addition or subtraction, so just be careful of that. Okay, so the laws. Product of power says x to the a times x to the b. When I'm multiplying powers of the same base, I add the exponent. So we write that algebraically as x to the a plus b. Quotient of powers, when I'm dividing powers of the same base, I subtract. So I'm going to say x to the a divided by x to the b, or I did it the other way. Sorry, x to the b divided by x to the a will equal x to the b minus a. And then a power of a power, x to the ab, equals x to the ab, x to the a times b, okay? A reminder that these guys only work when the bases are the same, okay? So if this had been 3 to the a times 7 to the b, then I can't put those together, okay? All right, then we have a power of a product. X y to the a equals x to the a y to the a. So if everything inside the brackets is multiplication, the exponent will apply to everything inside. Or if everything in the brackets is division, the exponent will apply to everything on the inside, okay? But again, just remember that these don't work. It's not the same thing if there's subtraction or addition there, okay? All right, let's talk about a to the 0. What is a to the 0, and can you explain why? Well, I have it on the slide there, but I kind of want to walk you through it for a second. A to the 0, I could write that as a to the x minus x. Do you agree that I haven't mathematically changed anything yet? Okay. A to the 0 is a to the x minus x is 0, so that's cool. But now I'm going to think about exponent laws. If I was subtracting the exponents, I must have at one point been dividing, right? We just talked about a law that said when you're dividing powers of the same base, you subtract the exponents. So this would then be a to the x over a to the x. Well, that's a number divided by itself, and anything divided by itself is 1. Anything to the 0 is 1, okay? So that's a helpful thing to remember. Okay, simplify the following. -3 to the 2. The -3 is part of the what the exponent applies to. So it'd be -3 times -3, which is +9. Be careful with the next guy, because some of you may have looked at that and said 1, and the answer is not 1, because an exponent only applies to what's directly in front of it. What's directly in front of that 0 is just the 6. So this becomes negative whatever 6 to the 0 is, and 6 to the 0 is 1. So my final answer would be negative 1. X to the 2 times x to the 9. When I'm multiplying powers of the same base, I add the exponents together. So x to the 11. Okay, just going to clear that ink before we keep going. All right, negative 13 d to the 0. Well, d to the 0 is 1. So that means I've got negative 13 times 1, which is negative 13. We'll go over here. I want you to see this as dividing. Now, they're out of order, but you just group the similar ones together. So I've got x to the 8 divided by x to the 2. That would be x to the 6. And I've got y to the 7 divided by y to the 4, which would be y to the 3. So x to the 6, y to the 3 is my final answer there. And then this guy, the exponent that I see on the outside, this 3, will apply to the negative 2. It applies to the a to the 4, and it applies to the b to the 3. Now, what happens is I get a lot of kids who will say, okay, a to the 4 to the 3 is a to the 12. I'm going to multiply that together. That's great. And b to the 3 to the 3 is b to the 9. I'm going to multiply that together. That's great. But then they screw up and they say, okay, negative 2 times 3. It's not negative 2 times 3. It's negative 2 to the 3. So it's negative 2 times negative 2 times negative 2. That's going to actually give you a negative 8. Okay, so just be careful with that. Negative 8, a to the 12, b to the 9. All right, now let's tackle this guy. So I've got multiplication going on and I've got division going on. Let's take the top and we'll just multiply it first. So that'd be, I multiply the numbers together and I multiply the letters together. So 6 times negative 3 would give me negative 18. M squared times m cubed. I'm multiplying powers of the same base, so I add the exponents together. That'd be m to the 5. And then n times n squared, that's n to the 1 times n to the 2, so that'll be n to the 3. So just doing that multiplication, I get negative 18, m to the 5, n to the 3, and then it's still over 27m squared n. Now, be careful with this. Don't you dare ever write me a decimal here, okay? What I want you to look at that and think is, okay, just think about that as a fraction. Negative 18 over 27. Well, both of those are divisible by 9, so that would reduce to negative 2 over 3. So you're just going to have negative 2 over 3 as part of your fractional answer, okay? M to the 5 divided by n squared, when you're multiplying powers of the same base, you subtract the exponents. So that'd be m3. And then n to the 3 divided by n. Why we use the letters m and n at the same time, I have no idea. It's always a tongue twister. That's n to the 1 on the bottom. Just remember that. So 3 minus 1 is n squared. So final answer would be negative 2 m cubed n squared all over 3. I also want you to take note that I still wrote it as one big beautiful fraction, okay? That's always the better way to answer it in math. Keep it all together and all is one fraction. Okay, so today is just meant as a quick review to make sure we're all on the same page. You've got some questions there that you can try out for homework. And if you have any questions, you can come and find me. In the meantime, have a fantastic day. And next up, we're going to start talking about radicals. Take care, guys.